Hello and welcome. Today we'll be visiting section 7.3, another work on volume. This time a new method, the shell method. So in 7.2, basically we formed little washers by spinning a rectangular solid around the axis. Now we're forming solids sort of one outer layer at a time, creating something kind of generally the basic shape of a roll of tape. We keep adding on more and more layers until we find the actual volume. So keep that shape in mind when you see my beautiful 3D renderings here. So the idea is we've got a tube. So the inside is hollow, outside is solid. Again, like our duct tape. This is the gray tape area, this is a hole. And we're going to have a couple measurements with this. P is going to be from the center of the circle to the midpoint of the, we'll call it the tape section, the midpoint of the shell that we're examining. Now, the full length from the outside to the inner rim, we'll call that W. And we'll call the height of the tube, not so cleverly, H. No big surprise there. So the idea here is if we want the volume of this tube, we'll take the volume of the outside. So if we were to take the entire thing as if it were all filled in, the whole thing filled in, no holes, we would take the area of the circle and multiply by the height. Just think of how you would find the volume of a soup can. So pi times radius, our outside radius is P plus half of the width of the solid object. So volume of a circle, pi times r squared, so we're squaring this, and since we want to have that go all the way across, we have height h. So that's our outside part. And then we cut off the inside part. The inside part, pi again, since we're talking area of a circle. Our radius this time, P minus half of W. And again, we're squaring since we want the area of a circle. So pi r squared times the height. So that's our inside. So after that, it's just a matter of playing with a little bit of algebra here. So our volume, pi, then foiling this out, p squared plus pw over 2 plus another pw over 2 is plus pw. And then plus w over 2 times w over 2, w squared over 4 times h. And then I'll FOIL this other guy out as well. P minus w over 2 times another p minus w over 2. So that's p squared. We have minus pw over 2 minus another pw over 2. 2pw over 2 is pw. And plus our w squared over 4 times h. And there we go. Let's get that in frame. Okay, so we foiled all that fun stuff out. Now a little distributing, and we get some nice canceling. So our volume, each of those have a pi and an h attached. I'll just grab those to the front of the line for the moment. And then we have p squared plus pw plus w squared over 4. Distributing this minus sign, we have minus p squared plus pw minus w squared over 4. Again, we already pulled the pi and the h. So our volume, pi times the height. All right, p squared minus p squared, goodbye. W squared over 4 minus w squared over 4, goodbye to that as well. So we have plus pw plus pw. So that would be 2 pw's. So our volume, 2 pi times h times p times w. So that would be, in general, how we find the volume of a shell. So for example, again, if we want to find the volume of the amount of duct tape that we have, this is how we could go about it. Now in terms of calculus then, change in volume, we'll pull that 2 pi, those are just constants, times b of y times h of y times delta y. So let's make a quick sketch of what we're doing here. So we have some type of object. Let's say this general shape here, this lovely piece of artwork there, and we're spinning it around the x-axis. So the change in volume of this thing, 2 pi is there automatically since they're just constants. Py hy times delta y. So delta y is, if I put a little representative rectangle in this, here is our delta y, the width of that rectangle laid horizontally. Here to here is h of y, and representative piece here, p of y. So if that's delta v, then v must be 2 pi integral from, we'll just call it from c to d, of p of y, h of y, times delta y turns into then dy. So we get the same volumes out of the washer method and shell method. The one important difference is there are certain problems that the shell method can handle that the disc and washer method simply cannot. So we'll look at some that can be done both ways, and some that we don't have a choice and would have to use the shell method. All right, so let's see. I want to get all this example on one page. We'll flip here. All right, so we're going to find the volume of the solid represented by formed by, my apologies. So find the volume of the solid formed by revolving the region. Y equals opposite of x minus 5 quantity squared plus 4. So you should recognize that as a parabola. It's opening down. Vertex is at positive 5, positive 4. Hopefully you remember that from your college algebra days. And the x-axis. So we have a parabola, vertex at 5, 4. Again, I'll just draw a quick dirty sketch real quick. There we are, opening down, x-axis. So this is the general shape that we're going to have, and we're going to revolve this region about the y-axis. All right. So first a few sort of key points on here, and then we'll draw our representative rectangle. So we already said the vertex is up here at 5, 4. It's not compressed or stretched, so 1 unit away we go down 1, 2 units away we drop down 4. So then this puts our intercepts here at 3, 0, and 7, 0. If they don't turn out nice and neat like that, just set these two equal to each other. X-axis, remember, is the equation, y equals 0. Okay, so our representative rectangle, let me increase the size of that a little bit, just make it a little bit easier to see. So there's a representative rectangle. We're flipping it again around the y-axis. So our radius, this would be our p of x. So then our height here, h of x. And our thickness, of course. Then this way would be delta x, turn the other way, delta y. So our volume, shell method, we always have this 2 pi. So you're always going to see that in a shell method. Integral from, we are going from x is 3 to x is 7. Times p of x. I'll go ahead and write this down just so you remember it. So a to b, p of x, h of x, dx, or equivalent with y's. So p of x, our radius, well, we went from 0 to wherever this x is, that is a radius of x. H of x, though, the height of this, is guided by the y is equal to the opposite of x minus 5 squared plus 4. So that is our h of x. And, of course, delta x then becomes dx. Okay, a little bit of simplifying to do that. So our volume, hang on to the 2 pi, integral from 3 to 7, and just a little bit of cleanup work here. So x times, let's see, opposite of x squared plus 10x plus 25 minus 10x. Once we flip, it'll be plus. And plus 4, closing on up, times dx. So x minus 5 times x minus 5. X squared minus 5x minus 5x. Negative 5 by negative 5. So our volume, 2 pi, integral from 3 to 7. I'm going to go ahead and hang on to this x for a second. So opposite of x squared plus 10x. And then we have minus 25 and plus 4. So minus 21 times dx. So our volume, 2 pi integral from 3 to 7 of minus x cubed plus 10x squared minus 21x. Close it up and multiply by dx. Okay, so now we're free to just use that power rule again. Just think of differentiating backwards. If you were differentiating y is x squared, you have 2x to the first. Now we're working backwards from that. So hang on to the 2 pi for the moment. X to the third, we bump up the exponent, that's an x to the fourth. To avoid having a 4 out front here, I need a 4 at the bottom, and to include the negative that I don't see yet, we'll use a negative 1/4. So 4 times negative 1/4 is negative 1. So differentiate in your head to make sure it works out, that you can go backwards that way. Okay, similarly our next term, x squared, antiderivative, so now it's an x cubed. I did see a plus 10, I did not see a 3. So what you had, what you didn't have. X to the first is now, excuse me, x to the second. I didn't see a 2 there, so 21/2. And we'll evaluate those from 3 to 7. So our volume is 2 pi times a little plug and chug in the calculator, and we get 220/3. So our volume is 440 pi over 3 cubic units. And again, I would prefer the version with pi, not the approximation. So this was one that could have been done using the disk method. This was the washer method, however. All right, let's see. Go back to that one if we can. All right. So our next one, we're going to work with something that we saw already in section 7.2. So if you'll recall, when we did the problem involving y is x squared plus 6, y equals 0, x equals 0, x equals 2, and we were revolving about the y-axis. Just a quick sketch of what was happening. So we had our parabola opening up from x is 0 to x is 2, and we were spinning around the y-axis. So we had to, remember, cut this into 2 chunks if we were going in via the washer and disk method, respectively. Shell method is actually a little bit simpler. So same initial setup on this. Make a similar, very lovely drawing here. Only now, here's my one representative rectangle for the whole thing. I don't need one for here and a separate representative rectangle up there. So here's our P of x, here is our h of x, and our width is delta x. So volume, 2 pi integral from a to b of P of x. So radius, h of x height, dx. And I recommend, as many times as you have to look back at the formula, each time you have to look back at it, make yourself write it down again until it sticks. So our volume here, 2 pi times our integral. Recall they told us we're going from 0 to 2. Our average radius, 0 to x, is just x. Our height, that's governed by this y is x squared plus 6. And our thickness, dx. So our volume, 2 pi integral from 0 to 2 of x cubed plus 6x, close it up, times dx. Hang on to the 2 pi, and now we're doing the antiderivative one piece at a time. So x to the third, antiderivative, we add 1 to the exponent. I don't see a 4 here, so I'll need a 1/4. So that when we differentiate, the 4 and the 1/4 cancel to give you the nice, neat, pretty 1 we saw there. X to the first, again, power rule, becomes x to the second. You can either do the 6/2 or you can mentally turn that into the 3. Just think of what you would multiply 2 by to get the 6 there. 3 is what you would get. If you need one more step to write it as 6/2, that's fine, and get the 3 the next step. That's okay too. And we're evaluating this time between 0 and 2. So our volume is now 2 pi times, we ended up with 16. So our volume is 32 pi cubic units.